I can't able to see the screen. It's visible now.
Okay, yeah. So we were on module 3, right?
Yes.
Okay. So this was already done. This was also done. Okay. Walkthrough done. And we discussed about the domain project as well, that it will be used only in your on-prem. Right?
Yeah.
Class loading lifecycle also, I provided you some links as well, like how your classes are being loaded in the JVM to be executed. So this was the procedure, this was the diagram for that. And after that, yes, we have done this as well, like configuring the schedulers. I have shown you that we have these, like, I have told you that we will be getting the time zone, but that time zone will only be used for your RTF or on-prem. It will never be used for the Cloud Hub deployment,
Okay.
right? So scheduler and versus runtime, this was also done. Transform data structure using the data weave. Okay, so for this also, I have shown you the WLang uh, folder, that jar file, right? In which you will be able to find all your modules, existing modules. Right? Even I told you that you can visit my LinkedIn page as well. On my LinkedIn page, I have posted so many cheat sheets and even the slides where I have explained about the data weave modules.
Okay.
Okay. And other than that, there was a walkthrough that was very simple. And related to the error handling also, we covered one more error handling that is not defined here. That is runtime, how with the runtime uh, module, we can do error handling in the data weave. Right. So on error propagate, on error continue, all done. Setting global error handler, done. Triscope was done. I
No.
think it was. Okay. Okay. Yep. So let me open Paint. Sorry for this. Okay. So what we have, first one is we can do flow. Sorry. Okay. First one is flow level error handling. Why it is not? Okay, just give me a second. Yep. First one is your global error handling.
Okay.
Error handling, right? So you can create this global error handling. I have shown you that one as well. Like you will get the option in the configuration, right?
Correct.
I remember that I have showed you, right? Why this is okay? Perfect. Second was your flow level error handling. Okay. So in the flow we have one thing that is error handling, where we can define the errors for all the flows, where we can add on error propagate, on error continue, right?
Yeah.
Third one is your connector level. Okay. So for connector level, you can use triscope. Okay. So like for particular connector, if you want that, if you think that this connector may throw the error that you want to catch and you want to give your own custom messages and all, then you can use triscope for that. Okay.
Okay.
So let me move. Let me open this thing that doctors again. Okay. Okay. So this is flow level error handling, right? And
Mhm.
this is also flow level, and difference is on error continue and on error propagate. And I asked you one question related to the on error propagate and on error continue. You were right in that, like that hi message or hello message, right? So you know how these two works, right? So let's say if you're having a subflow, okay, subflow is there. Sorry, subflow. Okay, and inside this subflow you are having some transfer message. Okay,
Mhm.
and you added some code where, let's say, you are trying to do the mapping for attribute which is of string type, and you are thinking that it will be a number, and you're trying to multiply that with the with another number, that is 2, let's say, right? So
Mhm.
that will definitely throw the error, right? So if you want to
Mhm.
handle this error for this particular connector, what you can do, you can add it inside the try scope.
Mhm.
Okay?
Mhm.
So in the subflows also you will be able to do the error handling. Okay. And let's
Okay.
say if you are having a flow, and in this you are having multiple connectors, and even you are having error handling as well. Okay. But for one connector you want to do different type of error handling, then also what you can do, you can add it inside the try scope.
Okay. Okay.
Okay. So
So
this
I
is
have one
one way.
question.
Yes, yes.
Uh, so we have like try block in the sub flow.
Hmm.
In the main flow, we have on error continue. Yeah. So
Hmm.
sometimes when we are define the error,
Hmm.
so which one is priority? Like, is it
Hmm.
override for the main flow, error
Hmm.
continue, or how to handle this one? Let me repeat my question. So
Hmm. Hmm.
if we have like two errors handling for the subflow and the main flow, yeah.
Yes,
So
yes.
yeah, so if which one is like for the subflow, which one is like the main error or the try? Like sometimes conflict
Mhm.
with the error handling. How are we going to handle that?
Okay, so it will be like if you're calling a subflow from another flow, right? So, and
Yeah, yeah.
in that subflow, you are having on error propagate. Okay, that means that subflow is going to return error to your main flow. But in main flow, let's say if you are having on error continue, okay, then this on error continue will be used. Why? Because from your subflow, it returned error. Okay, it returned error. That means here it got failed. Now it will check for here. Let me explain you with the diagram.
Mm.
Let's say this is your main flow, okay, and this is your subflow, okay,
Mm-hmm.
and inside the subflow you are having one try block here, okay,
Okay.
and let's say it got failed, and this try block was called from this main flow. Let's say there are three connectors, okay, and here your error handling is also there. Okay,
Mm-hmm.
and you call this flow from here,
Mm-hmm.
and here also there was one connector, and here also there one connector. So it got failed here. Okay, and inside this you were having on error propagate. Okay, so you
Mm-hmm.
always know that it will return the error to the parent, right? On error
Okay.
propagate, what will say? It will be returning the error message to the parent. That means it will return failure to this one, your main flow, because it was called from here. This one is the
Mm-hmm.
parent, right? So
Okay. Okay.
here,
Yep.
if you are having on error continue, then it will be executed. First, this one will be executed, but then this one will be executed. Okay. But
Oh.
let's say you are having try block here.
Mhm.
Okay. So you are having try block here, and here also you are having error handling, and here also you are having error handling. Okay.
Mhm.
So in this stage, and let's say it got executed successfully, but here this connector got failed. Okay.
Yeah.
Then this will be executed, not this one.
Oh, okay.
Okay.
Okay. Mhm. For the
No, no,
subflow,
no, no,
both
no, no,
the
no, 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 no. My bad,
sorry.
my bad, my bad, my bad. First, this one will be executed because whenever you add a try block, okay, that will consider whatever it is inside the try block, it will be considered as separate flow. Okay. This is
Mhm.
considered as a subflow for this main flow. Okay. So it will return either success or either failure. Okay. Let's say this is on error, propagate. Okay. Then this
Mhm.
will be executed. But if it is on error, continue, then this will not be executed. Clear?
Can you repeat?
Yes.
I
Okay.
was.
So this is your main flow, this big one,
Uh-huh.
big box, right? And this one is your try block, this one,
Okay.
right? So whenever you add a try block, let's say if a try block is having 3 connectors, okay? So
Okay.
this whole try block will be considered as your subflow. Let's say in layman terms, it will be like a subflow for this main flow, okay?
Mm-hmm.
So, so whenever there will be any error and error handling is done, let's say you have error handling that is on error propagate, EP,
Okay.
okay? So on
Yeah.
error propagate is there, then you executed some error handling and all. Okay. In this case, this parent will return error to this one, this main flow. Then this will be executed.
So like we have like that's my question. So we have like try block error handling and main
Hmm.
flow error handling.
Hmm.
So
Hmm. Yes.
first you say like it executed the first try block
Hmm.
and like if it is failed like the try block flow,
Hmm.
so so it goes to the main flow.
Hmm.
And how about the main flow error? So why we need like two error handling? So if it is goes to the main flow,
No, no, no. In
that's my.
some cases, let's say I want for this connector, in case there will be any issue, I want the successful to be there.
Mhm.
If I add on error propagate, oh sorry, on error continue, then it will
Mhm.
not go here, no?
Mm.
Okay,
So
let me
like
explain you example.
okay,
Just a
let me
second.
repeat one question. So always my confuse is we have like for example try block error and the main
Hmm.
flow error handling. We have
Hmm.
two error. One is for try block, the other is for
Hmm.
main.
Yes.
So when the try block is error happened, so is
Hmm.
it going to where did it go this error for? Is it go to the main flow error handling? I was confused that one.
No, 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 no. See,
Mm,
let's understand with this with the example. Let's write a code for this. Okay, it will take
mm.
2 minutes only. Till this one is creating, I think we can do something else for now. Okay, so try block. Okay, So let's say if you are not having error handling, you just want to have a error handling for some specific connectors, then also you can use try block, right?
Okay.
Okay. And in some cases, where I was explaining this, let's say you are having a try block. As I said, that try block, you can consider this, it will act like a separate flow for you, right? This
Okay.
will,
Okay.
so let's say you have some connectors. This is, let's say, transform messages are there. Okay. So there are multiple transform messages. This is also, let's say, transform message, and this is also transform message. Okay. And here also it will be a transform message.
Okay.
Let's not consider as transform, sorry. Let's consider this as a request connector. Okay. So request connector is there, request connector is here in the main flow. So this is the main flow. This whole flow is a main flow, and inside that we have one try block here for this connector. Okay. Let's say this request connector is used to send the notification to the customer. Only the
Okay.
notification. Okay. And these are the actual ones to get the data.
Okay.
And this is just to send the notification. So let's say if this one will get failed, I don't want any error. I don't want any error. I just want to send the notification to the customer that it got failed, but I don't want to handle that in the same way these errors are handled. Correct?
Okay. Yes.
Because
Yes.
here I'm not getting any data. It's just for notification. So what can I have it here? I can have on error continue.
Okay. Okay.
On error continue, and I can handle the error. Let's say for this notification, if this will get failed, I just want to add this in one file, that this got failed. There is one local file and I'm going to add the data here, there. That's it.
Uh-huh.
Okay.
Okay.
So
Okay.
if this will be executed to the main flow, it will say I was successful. It will not say I was failed. Okay. So it was successful. That means other connectors will be executed correctly,
Okay.
right?
Uh-huh.
This
Yeah.
one, this error handling will not be executed for this, because this was connector level error handling, right? Now you got the
Yeah.
example. Use case is clear.
Yes. Now I understand because so one the error the try block error handling is execute. We don't go to the
Hmm.
main error handling.
Yes,
We only yes. That was my question. So sometimes
yes.
if it is
But if
yeah.
on error propagate will be there,
Uh-huh.
then it will go,
Oh.
because
Okay.
this will say that I got failed. Clear?
Yes. Yes. Now clear.
So I think this project is not required now. You want me to
Yeah.
create the project to understand, or it's fine? We can skip because we don't have much time now, right?
Yeah. 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 You can continue.
Okay,
Now I understand. Yeah. Yeah.
perfect. So we have one more option that is called raise error. Okay. So here, as I said, that connector level is there, flow level is there, global error handling is there. There is one more level that is called your data weave level. Okay. For this, your runtime module will be used. Runtime module. Okay. In this runtime module, you have try, you have fail, you have fail if. Okay. You want to see? I can do this. 1 minute. It will take only 1 minute. Okay. So let's say in a payload dot message we have this hello world. Okay. So I want to import first. Import star from DW runtime. Okay. And here, let's say I say if my this message is equals to 2, then fail and give error, that is this is incorrect value, let's say, right? And else you can just say hi for now. Okay, so for now hi will be printed because the value is hello world. Okay, let's say I
Okay.
print 2, then C. Now it is printing my error, whatever I want, what I'm printing here, right? So this is how you can generate errors using data weave. Clear?
Okay.
See, I'm saying
Yeah.
that if the value is 2, then generate the error that says this is incorrect value.
Okay.
Hello.
This is syntax
See,
error, like everything.
no,
So
this
is
is
it?
not syntax error. See, error message is being printed. What I am trying to, it's conditional based. It is like a raise error. Okay, it is like a raise error, custom error
Oh, yeah,
handling
yeah.
for data weave.
Oh, okay,
Because
okay.
some
I
customer
read.
says that if I will get this value, please raise the error, right? In
Okay,
that
this
case,
is.
you can use it. Because let's say you are getting the array, okay, array of, let's say, CSV file is there, and in CSV file there are 5,000 records, okay, and
Mhm,
you are doing the mapping on those all 5,000 records at a time, okay. So in
mhm.
that case, if the value is not there only in one row, then also you want to raise the error, then you can have this data weave error handling for that, right?
Okay,
Because
okay.
for adding the validation, that validation is also there, validation connectors are also there, right? For validation connector, what you need to do, you need to add for each or parallel for each. Inside that you will be adding this validation
Okay.
thing, right? So rather
Yep,
than
yep.
doing that, you can directly handle the error inside this, okay. But the thing
Yep.
is, the error type will be always expression, okay, because transform message gives the expression type of error. Clear?
Correct. Uh-huh. Yep, yep.
Yep. So let's go back here. uh when and how the system errors occur. Okay, so in case some system errors occur, or related to the network issues, related to the database and all, what you can do, you can check the logs for that to understand that how it works, right?
Oh, yep,
And
yep.
to handle that, you also have two blocks, two scopes, that is until successful, and another one is retry,
Mm-hmm.
right? For until successful, it will come in future, right? So let me explain now only. That time we can skip. Okay, let's say this connector is there, that is request connector, and customer says if you hit three times, only one time you may get successful. Okay,
Okay.
so in that case, what you can do, you can add a until successful, and you can add your request connector inside that. Okay, and in
Okay.
until successful, you can configure this. You can say that, oh sorry, so until successful, you can say that maximum retries may be 5, or let's say if customer is saying 3, you can add it 3 as well. Okay, and you
Okay.
can provide the milliseconds of the time between the retries. Let's say the first retry was first hit was at 7 p.m. and then you want it at 7:05, then you can add it here. But remember one thing, it will hold that thread, okay, that thread for that particular time.
Okay.
Clear?
Okay. Yep. So let me add
Yes.
one thing. Can we
Mhm.
add like try inside the until successful, like try scope?
You can add, but there is no use for that. You should always add try outside the until successful.
Yeah, outside, but so.
Yes, yes. You
Okay,
can add
okay,
inside also, but I always like suggest you that you should go for outside. Outside.
okay. So now, okay.
Hmm.
So this is why we need like try and until successful.
Yes, let's say if this will get failed 3 times, sorry, 5 times, because the value is 5 here. If it will get
Uh-huh.
failed 5 times, then only this error handling will be executed. Otherwise, error handling will not be executed. Okay.
If
But in case you add this try inside the until successful, then each and every time that error handling will be executed in case of failure.
for example, if you don't have like error handling, can you do try? Why we need try? I saw some places they put try and until successful. So I don't know why they
Uh,
use both these two, how they are working.
hmm, I always prefer it should be outside, because every time sending the error is not that good. But yeah, if you want to send the notification to the customer, to make him understand, see that after every third hit it is getting successful, otherwise it is getting failed, right? So
Uh,
in that case you can add try inside as well. Okay, so in
mhm.
every retry it will send the notification to the customer. Yeah.
Okay. Yep. Okay. Got it.
Yes, so let's go back. So in this one is that, yeah, in request connector, in the configuration you will see one. uh, where is that, where is that? I wanted to show you something. I think this one, reconnection is like a retry. Okay, retry strategies are there. Okay,
Mhm.
first one is none. Okay, so where you are not using any strategy for reconnecting. Okay, reconnection means, let's say, there is a huge difference between until successful and reconnection. Okay, so until successful means your connection was already built, right? And you are just
Mhm.
you are just sending the request again and again with that connection only. Okay,
Uh-huh.
and reconnection and retry is you break the connection that was already there and you try to reconnect again. Clear?
Mhm.
So that is the huge difference between your until successful and retry.
Not
Okay.
clear. Can you repeat? So I just.
Okay. So let's say you are sending the request, okay, from this one. Okay, this is a request
Mhm.
connector and you are sending the request to database, some
Okay.
database. Okay,
Mhm.
so let's say you got the error, you got some error, let's say timeout was there.
Uh-huh.
Okay, and other time you got the error related to the authentication and all.
Mhm.
Okay, so in that case you can use until successful
Okay. Okay.
to handle that. Okay, but let's say it is related to the connection, that connection is getting break again and again or getting implemented again and again. In that case you can use retry. Okay, retry, what it will do, it it will, if you are having already built one connection, okay, so in until successful with the same connection, let's say if you're sending a message from here A to B, okay, for sending the
Mhm.
message one tunnel is there, right?
Okay.
One tunnel will be created, and by this tunnel you are sending the messages, okay. Until successful will send the message again from this tunnel only, always, okay.
Okay.
But if you add retry, what it will do, it will destroy this tunnel and add a new tunnel, and from that tunnel it will send the message. Clear? It will
Yeah, but I
break
have one
the
question.
existing connection and then create the connection again.
New- So it looks similar, but for example, until successful, mostly, for example, if there is connection issue in the database, so we
Mhm.
are trying, you see, like maximum 3 try. So the same way we will try to connect our database, yeah. So
Yes, yes.
uh,
But in retry, it will create a new connection. It will not use the existing connection.
that is
Okay.
a
And
difference.
until successful, yes, in until successful, you are sending the request again from this tunnel only, which was already created. That connection
Okay.
was already created, right? But
Uh-huh.
in retry, it will break this connection and create a new connection. So this is the
Uh,
difference.
okay. Got it. Got it.
Okay. So retry will always used in case of the connection stuff, in case of the errors related to the connection only.
Okay. Okay.
Okay. And here standard is there and forever is there. Just a second. In the standard, you can define that there will be this much of reattempt can be done. Okay.
Mm-hmm.
I will study about this one. I am not that sure about the reconnection because I haven't used that, but I will study about this. I will come back to you. There was one more
Okay.
thing that I need to go through, right?
Mhm.
Where is that? Sorry, these are the books names I need to read.
Okay.
Uh, okay, so this one, and there is one more question. Now I will go through this. Till next week, I will give you answer for these two questions. Okay.
Okay. Sure.
Yes, let's go back to the slides again. So, common mule connectors. Okay. So, it will cover now the common mule connectors like your HTTP, your database, file, FTP, and all. Okay.
Mm-hmm.
So HTTP connector supports both client and server operations. Okay. Listen for inbound over HTTP and HTTPS. Okay. To trigger the flow. Okay. So it will be
Okay.
added inside the source part. Right. So send the
Okay.
HTTP and HTTPS request in the middle of the flow. Okay, so request connector can be used. And next one is HTTP 1.0 and 1.1 are supported. For now, HTTP 2.0 is not supported. So whenever you will be hitting the API of a customer, okay, first please ask him that which HTTP version they use. If they are using HTTP version 2.0, then this request connector will not be able to work properly.
Oh,
Clear?
okay. Yeah, clear.
So next thing is uh, related to thread pools. Okay, this is
Mm-hmm.
the important thing, and this is most interesting one as well. Okay, I will be
Okay.
showing you some practical stuff for this. Clear?
Okay.
So it says that for HTTP connector, it will use the Grizzly library internally. Okay. So Grizzly is a library, okay, which is being used by your HTTP connector, okay, for the threads, for handling the threads. Okay, so it says
Mhm.
that Grizzly is your open source library supporting HTTPS. Okay, so Grizzly
Mhm.
is of two types. There are two types. First one is shared Grizzly, and another one is your dedicated Grizzly. Okay,
Mhm.
so for listeners, the shared Grizzly will be used. That means this same Grizzly will be shared by multiple listeners. Okay, but the
Okay.
dedicated Grizzly will be used for your request connector. That means each request connector will be having its own Grizzly, like its dedicated Grizzly thread pool. Okay,
Okay.
thread pool is a, let's say, bundle of multiple threads. Okay, so uses selector thread pool, selector threads, checks the state of NIO channel. Okay, this is not that important. Okay, so listener selector polls only for the request events. Okay, so listener thread only polls for request events, whatever the request we are getting, and requester connector only polls for the response event because it will not see the request again, right? So whenever you
Okay.
send any request using the request connector, okay, so in the response you will not be able to see what request you sent to the request connector,
Mhm.
right? So what you are sending here, after this you will not be able to get that. This A is now converted to B. You will get the B here. You will not be able to get A. For getting A, you need to add this inside variable or something, right?
Uh-huh.
Okay. So HTTP listener has a shared selector pool. Okay. As I was saying, that shared Grizzly for all Mule applications deployed to the particular Mule runtime. Okay. And HTTP requester has a dedicated selector pool for each Mule application. That means in the runtime, let's say you have deployed 5 applications, okay, then same thread pool will be used by your all the application for listener,
Okay.
okay. But for requester connector, okay, each application will be having their own dedicated pool. Clear?
Okay. Yep.
Or you want me to
So
explain this with diagram?
yeah, yeah, I have.
Okay, okay.
This is
No
new.
issues.
I, yeah.
Okay. So let's say this is your runtime. Okay. And you have deployed 4 applications here. Clear?
Uh-huh.
This is your runtime, Mule runtime. And here, Mule 4 applications you have deployed. All 4 I have deployed. This one, and this one, and this one. Okay.
Okay. Uh-huh.
Let's go back. Now, for the request connector, let's say for the listeners. So everyone will be having listeners. Okay. So Mule is having threads. Okay, because it works on your Java, right? So it
Right.
will be having threads. Okay. So let's say there is one thread pool. This is one thread pool. Thread pool is a collection of threads, you can say. Okay. So collection of threads, this is for listeners.
Mm-hmm.
Listeners. Thread pool for listeners. Okay. And there is one more thread pool that is for requester. Let's say R1 for now. Okay. So, just a second. Okay. So
Yeah.
here in this, you are having requesters also in the flow. Okay. So these are the listeners. This is a listener. Okay. Let's not use this. Let's directly say that this is a listener 1, this is listener 2, this is listener 3, this is listener 4. Okay. And there could be multiple flows as well in each application, because this is one application. Let's say this is for orders, and inside orders there are 5 flows. For now I am just considering one for now. Okay.
Okay.
So, and there is one request connector as well. Let's say R1, R2, R3. This is a transform message. Okay. So for all the listeners inside this Mule runtime, okay, they will share the same thread pool.
Okay.
Okay. But for requesters, for each application, let's say there are multiple flows and that is having R. Okay. That means for each application, there will be one thread pool. For this one, this one, this, and for this one, this. Dedicated. Okay. And these are grizzly thread pools.
Okay. Okay.
Clear?
Instead of for listener, we only we shared, but when you come to request connector, it's supposed to be each flow the thread
Not
pool
each flow,
for
not each flow, each application.
each
This is
application,
one
for each
application.
application.
Yes, yes,
Exactly,
yes,
each application. Yes. Yeah. Yeah.
yes. Okay. And for testing these things out, what you can do, you can download one tool that is called VMware.
Okay.
Okay. VM.
Okay.
Okay. So let's go back to slides. This is done. Okay. This you can find on the internet also. This is not that important. Okay, another connector is JDBC. JDBC connector, you know that it supports DDL, DML. Okay, DDL, you know that is for data definition language, and DML for manipulation. Right. So
Okay.
data definition means that is related to your tables, like structure of the table, schema of the tables, and manipulation is like whenever you are inside the table, and inside the table you want to change some column value, you want to change some rows and all, right? Next is your stored procedure, DB scripts, bulk operations, on error tables. These will come under your JDBC, your database, right?
Okay.
So there are some SAS connectors that you can search on your Exchange that are already existing connectors. Okay. So these are some connectors for that. And next is your FTP connectors, file related connectors. So file is there, FTP is there, FTPS is there, SFTP is there, right?
Okay. Okay.
So, okay. So there was one question that you need to be like familiar with some connectors, some basic connectors. Okay. So there was one connector which was called IBM mainframe. Okay. And inside IBM mainframe, it comes IBM CICS. Okay, so there was one question which many people got this question in the exam, that IBM CICS will come under which module or which connector. Okay, then you need to write IBM mainframe. It will come under IBM mainframe.
Okay.
Okay, so this is how you can be familiar with the connectors.
Okay.
So these are some SAS connectors. Okay, so what you can do, uh, please don't take a snapshot for others. Okay, for this one I can provide you because this can be helpful for you. Okay, it's not allowing me to send you. Mm,
Let me try if I can.
yep.
Okay. Let me. Okay. Yep, I did already.
Yep. Okay. Okay, so some Salesforce connector is also there. Okay, so Salesforce application sends the events or the notifications that Mule applications consume to take further action. Publisher and consumer consumers communicate with each other through the events. Okay,
Mm-hmm.
this is not that much important. You can check out the Snowflake connector. Okay, for this. Building custom connectors. Okay. So you can create your own connectors also. So these all that we have covered some existing connectors. Okay. So you can create your own custom connectors as well. Okay. By writing a Java code and all. Custom connectors are used to integrate the existing business logic and algorithms. Okay. Choose OOTB components or web services like REST or SOAP over the custom components. Okay, so always try to use the existing stuff rather than going to create a custom ones. So if you will be
Mm-hmm.
creating a new connector, that means it will be using some new libraries. Okay, that are not existing. That means that may impact your performance of your application. First thing is performance, and let's say they may be incompatible with Mule. Okay.
Mm-hmm.
So build custom connectors only when the API or the connector OOTB connector does not support the use case. Okay. So first look out. What should be the first thing? First look out in the exchange whether the pre-built connector is there or not. Okay, so let me
Mm-hmm.
give you one example. So there was one use case where customer asked us to connect with SFCC, that is Salesforce Commerce Cloud. Okay, so
Mm-hmm.
in that case, what should be the first thing that we should do? Because the normal one is not there, the basic connector is not there to connect with SFCC for Commerce Cloud. So first check should always be to check in the exchange whether there is some existing connector or someone published that thing is there or not.
Mm-hmm.
Okay. Next is if you don't find the one, see if you can connect to the external system with the web service. Okay, so first thing is to check for the connector. Okay, let's say if you want to connect to the Salesforce, you will first see that the connector is available, that you can directly connect to the Salesforce. Okay, let's say there is another tool, okay, with which you want to connect, for which the connector is not available. Then first ask customer that they have that they have APIs to connect with the system or not. Okay. So
Mm-hmm.
second thing is to check for the available web services. That could be either REST or either SOAP. Okay. Finally evaluate if the worth of creating custom connector or not. Okay. That means if both are not available, then you can think of creating a custom connector. Otherwise, custom connector is not a good option. Okay.
Okay. Mm-hmm.
Next is types of Anypoint connectors and the levels of support. Okay. So there are 4 types of levels. Okay. Just give me a second. So first one is your MuleSoft community level. Okay. So there are some connectors that are developed by the MuleSoft community. Okay. Those are free to use, and even you will get the support from MuleSoft community for that. Okay. Like
Mm-hmm.
your HTTP and all. Okay. You don't need
Okay.
extra license for that. Right.
Okay.
Next one is MuleSoft certified connectors. Okay. That
Mm-hmm.
are developed by the partners. Let's say MuleSoft is having some partners, like say Epicero is there. Okay. So
Mm-hmm.
if someone from the partners developed the that connector, okay, and MuleSoft will first check whether the connector is correct or not. Based on that, they will provide the certification that this is a MuleSoft certified connector. Okay.
Okay. Mm-hmm.
But in case of any support for that connector, who will be providing that? The partner only. Okay.
Mm-hmm.
Because the partner created that connector. MuleSoft just reviewed and certified that connector. Okay. And it will be based on the partner that they want that connector to be free or they will be charging for that connector. Clear?
Mm-hmm. Okay. Okay.
So the third type is select. Okay. In select, the MuleSoft maintains the select connectors. Okay. And there is some subscriptions are required for this. Okay. For select connectors, it says that these are developed by the MuleSoft. Okay. Free to use, but the support is only for enterprise account. Support will not be provided for the trial accounts or to anyone. Okay.
Mm-hmm.
For that,
Mm-hmm.
you need subscription. Okay. Next is premium connectors. Okay. So premium connectors, MuleSoft maintains that connectors, but those are not free connectors. You need to pay to use them. Okay. In select connectors, you were using them by free of cost, but support was not free. Let's say if you find out one issue that and you are trying to use a select connector, and in that you want to add one more field, and only 3 fields are required, and you are trying to add 4 fields, and you don't know how to use that, and you ask for the support. So that support will be chargeable. Okay, you cannot ask
Oh,
for that support. Only you can use whatever that is existing. Okay. But in
okay.
premium connectors, even you cannot use that connector. That is not free of cost. Okay. Next thing is internally triggering the Mule 4 flows using the schedulers. So you can add a schedulers also to in the source to call the to add it as a trigger to call the flow. Okay. It could be at a fixed frequency. Let's say you are saying that in every 10 minutes it should run, right? Or you can
Mm-hmm.
even add a cron for that. Cron is like whenever you want to define that in the morning at 10 a.m. it should run always. Okay. So for that you can write a cron. Okay. In the cron, you can see that you can provide the frequency. Not the frequency. Whenever you will select the cron, it will ask you the time zone as well. And as I have already mentioned that in the Cloud Hub, that time zone value, whatever you are giving, will not be considered.
Okay. Okay.
Okay.
Mm-hmm.
That will always be UTC.
Yeah.
Okay. Or you can have the schedulers inside some other connectors as well. That we have already seen that on error on new table and all, we have the scheduling
Mm-hmm.
fields and all. Okay. scheduler behavior versus runtime deployment. This all also we covered. This was okay. No. Okay. Yes. We covered this one. We covered this one. One thing is cron related UTC. I have told you. And remember,
Mm-hmm.
I told you that let's say if we are having two workers, right? And horizontal scaling and vertical scaling I have covered, right? So in
Yeah.
horizontal scaling we will be having two workers or more than two workers, let's say. Okay, in that case if we are having schedulers, that will not be of any use, right? Because only in one worker that scheduler will be executed.
Right. Right.
Right. Okay, so there are server groups versus cluster. Okay, so what is server group, what is cluster? In cluster, the primary node will be created by itself, and in server the primary node will not be created by itself, and the cluster will always be sharing the memory,
Mm-hmm.
but the
Mm-hmm.
server group will have each server will be having its own memory.
Mm-hmm. Okay.
Okay. Mm, this is done. Transformation is also done. Error handling done. This also I have explained you that inside the configuration you will add this default error handler for global error handling, right?
Yes. Yes.
Okay. Triscope is done. Why I just copy pasted these things again and again. And then how the system errors. This is also done. Okay, routing mule events between the event processor. So for routing, we have some choice router is there, right? So choice
Uh-huh.
router will work on the condition based, right? So you
Right.
will be defining some condition, based on that you will go to the particular route. Okay,
Mm-hmm.
and the first successful one will be executed. Let's say in the first one you are saying if the number is greater than 2, and uh, in the second round you are saying that if the number is equals to 3. Okay, so
Mm-hmm.
and you send the number 3, then only the first route will be executed. It will not execute the second route. Correct.
Mm-hmm. Yep. Yep.
Next is first successful. First successful, what it will be doing, it will go to the all the routes, it will execute that, and which one will get first successful, that will be used as a response. Okay.
Okay.
Next is round robin. Round robin will execute all the routes, okay, but not at a same time. What it will do, it will give 5 seconds to one flow, 5 seconds to another flow, 5 seconds to third route, sorry, first route, 5 seconds, 5 seconds to second route, third route, 5 seconds, then again 5 seconds to first route, like that. Okay.
Okay. Okay.
And scatter together, what it will do, it will create separate threads. Okay, separate threads for each route, and all the routes will be executed.
For
Clear?
example, if one is failed, is it
Mm-hmm.
execute for scatter
Okay.
gather? Sometimes for in like
Okay.
parallelly, we are executing
Mm-hmm.
like we have three application. We are trying to send the same payload for that
Mm-hmm.
application. If one application is failed,
Mm-hmm.
gather execute. Uh,
No. Let's say if you are having three routes in the scatter together, okay, and if
mhm.
one will get failed, that means all will get. You will not get the response. It will not go ahead. Okay, but
Three.
you can
Uh-huh.
handle that. You can handle
Yeah.
that by using the triscope. Okay.
Okay.
In that case, you can use triscope. Always use the triscope inside the routes of the scatter together. so that it will be handled, so that one route will not impact the other routes.
Which means if we have like three database, we are trying to insert for the three
Hmm.
database. If for each database, we are putting triscope, you mean? If
Yes,
we are trying
yes,
to,
yes,
uh,
yes. Let me see. Let me explain you by this only. Uh, let's say these are the routes. This one is first, this is second, this is third, and this is fourth. Okay, and let's
yeah.
say this is your scatter together.
Uh-huh.
Okay, so this will be executed parallelly. Let's say this is like uploading the data to your database. Okay,
Uh-huh.
and this is
Okay.
getting the data from your database. This is also something like getting some data from file, let's say. Okay,
Okay.
and this is also pushing the data to the file, and you want that all to be executed in the like parallelly, because all are isolated. One is not
Uh-huh.
one will not impact the other one, right?
Yeah, yeah.
But let's say parallelly they are executed. Let's say this database got executed in 2 seconds,
Mm-hmm.
right? But this, while sending pushing the data to the file, it will get failed after 5 seconds.
Uh-huh.
Then this whole will get failed. That means your database was successfully uploaded. The data was uploaded. You cannot even roll back. It doesn't roll back the things, but you will not get to know, because in the end it will say that it whole process got failed, right?
Oh,
So in
yes,
that
yes.
case, what you can do, you can have a try block here. Okay, you know that this can fail, right? Sending the data to the file get failed. Okay, so you can
Mm-hmm.
add a try block here and add on error continue,
Okay,
so you
okay.
will get successful here.
Ah,
Okay,
okay. Yeah, okay. Yep.
so first successful, if you're having multiple flows, which one will get, like both are doing the same task, let's say the one which will get successful first, that will be considered.
Okay.
Okay, round robin, as I said, that same thread will be used, but it will process each and every flow time wise. Let's say it will give some time to this, then another time this to this. And handling, error handling, in the round robin, it says that only one route is selected each time. If the chosen route throws the error, the flow stops and the error is rethrown to the call stack. Okay, so in this case also you can use try block.
Okay. Okay.
So scat together, as you know that it will be like multiple routes will be executed in one go.
Okay.
Okay. Uh, we haven't we haven't completed transaction for now, right? That's why I'm not explaining this thing. Otherwise, there is one thing. Transaction topic is there. So if your flow is having a transaction, if your flow is inside the transaction, or you're using transaction, okay, and inside that transaction, let's say you are having scatter gather. Transaction means either done or not, right? So it
Mm-hmm.
will be like, it will be using only single thread. So for scatter gather also it will be single thread. It will be multiple routes, but all will be having single threads. First thread will be executed, then first route will be executed, then second route, then third route, like that.
Uh-huh.
Okay. So scatter gather inside the transaction will always be single threaded. We will go through the transaction concepts later on. Okay.
How about choose router? It is the same, yeah? It's not
How
single
about
thread. Multiple thread? No, choose router is multiple thread.
which router?
Choose choose router.
Choice router. Okay. Choice router always
Choice.
works on single thread.
Yeah, yeah.
Choice router is
So
always synchronous.
yeah, synchronous. So it's single thread, the
Yes.
same like
Yes.
Kafka. Okay, okay.
Yes. In scatogether, there are multiple threads. But if the scatogether is inside transaction, then it will be single threaded. Okay. Now the
Sorry,
result scattered.
can you
Mhm.
sorry, sorry. This is confused me. If okay, scatter gather is inside transaction, okay, it is single thread.
Yes,
Oh,
we will read about the transaction in later modules.
okay, okay.
Okay. So how your result of your your scatogether will look like. Okay. You will get the payload inside that. That will be like 0, 1, 2, 3, like that. That payload will be having this. So
Mm-hmm.
what this is called? Tell me what this is called. It's called Mule message. You remember Mule message, Mule event? Inside Mule
Mm-hmm.
event, we are having Mule message that is having your attributes and payload,
Yes, yes.
right? So your scatogether will always return Mule message. Okay.
Okay.
So you can extract the payload from that.
Mm-hmm. We are indexing. Okay.
Okay. And this is how the error handling will be done. As I said, that you can add a try scope. Okay.
Okay. Okay.
There's a walkthrough you can do. Comparing choice router with error handlers. That's also no use. Choice router is like a if then else logic. As I said, that in case your first one is true, then it will go to this one only. It will not go to second one,
Mm-hmm.
right?
Yeah.
Top to down, it will consider. Okay, and default also you can define. So the summary was Mule applications are built from various event processors. Okay. Mule events include the message and variables,
Mm-hmm.
right?
Yep.
The events message includes payload and attributes.
Mm-hmm.
Event processors include connectors and transfer message components. Okay. And event processors can be grouped into multiple scopes as well. Okay. That could be async or batch processing as well. Flows can configure various hierarchies of event handles. Now let's move to module 4. Okay. Let me check how many pages are there. Oh my god, 40 pages. Okay. So in the end of this module, you will be able to distinguish between the Mule for blocking and non-blocking and parallel reactive event processing options. Identify the event processing models used in various Mule 4 scopes, components. Okay. Identify Mule 4 streaming options and behaviors. Select appropriate event processing. Okay, describe the event processing options with JMS and VM connectors. Okay, and design the integration use cases with batch and near real time and real time data synchronization. Okay, John, give me a minute. Okay, I'm coming. Okay. Okay. So it says that the processing mod. John, you are there?
Yes, yes. Yeah.
Okay. So this is related to the processing models. So while executing a flow, which processing model can be used? Okay. So this will be based on that. So let's see what all event processing models we have. Okay. So there is one which is called non-blocking and concurrent. Okay. Next one is synchronous. Next one is asynchronous, then parallel processing, then streaming processing, iterative processing, real time, and scheduled one. Okay. So non-blocking
Mhm.
means your thread is not blocked. Okay. But it
Okay.
is concurrent. Concurrent threads are executed. Synchronous is like when you're waiting for the response, like request connector is there. Okay.
Uh-huh.
Asynchronous is your publish consume. Okay, you published the message, no matter uh, it got successfully processed or not, you just published it. You don't need to worry about who all are the consumers. Right.
Mm-hmm.
Next is parallel processing, like your scatter together parallelly, it is processing multiple routes. Right.
Uh-huh.
Streaming processing is mainly used for your files. Okay. When you are processing a file, very huge data, then you can add the streaming in that. Okay. Iterative processing, that means it is like a recursive loop or something looping like that. Okay. So
Mm-hmm.
where you are having multiple records. So for each is there, parallel for each is there, like that. Batch processing is there. Okay. Next one is real time and scheduled events. Okay. So real time is the, let's see what it will come. I think publish consume can come here as well. Some batch processing can also. Okay. Okay. I got it. I'm sorry. So real time and scheduled one are on table continue and those triggers, right? So in case there will be any new row got added, right? So that will be used.
Mm-hmm.
Yeah. So you got the
Okay.
brief intro for all these. Okay. So first one is your non-blocking and reactive. So what is reactive programming? Okay. So reactive programming, it says that the declarative programming paradigm that combines the concurrency with event-based and asynchronous systems. It's haven't explained well. Let me check out in my notes if I have any better explanation that could be useful, right?
Mm-hmm.
So where are my notes? Where are my notes? This is module 4. Okay. Okay. So for reactive programming, in my notes, I have written reactive programming is equals to your concurrency
Mm-hmm.
plus event based plus a sync system. So reactive programming is concurrency plus event based plus a sync system. Okay. This is for maximizing the throughput, and with a few resources, you can get more work. Okay. So this is called reactive programming. Some theoretical concepts.
Mm-hmm.
Because
Okay.
in reactive programming, what I understood, you know the language React JS, JavaScript. That is very like very famous in the market for UI creation. React JS that uses reactive programming. Okay. So whenever there is a change, any changes that is being done in the code, it renders it very fast. That is reactive programming. Okay.
Mm-hmm.
Okay. Let's go back. Features of reactive programming use the best ideas of the observer patterns, iterator patterns, functional programming, event stream. These are all theoretical concepts. Okay. How Mule for reactive streams automatically optimize the performance. Okay. Now comes one important topic, that is back pressure. Okay. So you are aware what is back pressure?
Not yet. I'm just.
Okay. So back pressure was not handled in Mule 3. Okay. So what it
Mm-hmm.
was, whenever you are getting concurrent requests, okay, let's say your server can accept only 100 requests, okay, but you
Mm-hmm.
are sending 200 requests at the same time, okay. So some
Mm-hmm.
incorrect response will be sent to the customer, okay. So back pressure, what it will do, it will check if the requests are more than 100, then it will send 503 server busy, so that it will let you know that server is busy for now, you can send your request later. Okay.
Okay. Mm-hmm.
So that is providing a signal. So this is so using the reactive programming, the first one is automatic. When we handle the back pressure, customer can receive 503 in case server is busy with lots of requests. Can be
Mm-hmm.
handled manually as well. For manual handling of back pressure, we can specify the maximum concurrent requests allowed. Okay. In case the request is greater than maximum concurrent value, we can acknowledge the customer 503. Let me check. So this is my flow. Here you can see maximum concurrency is written,
Yeah. Yeah.
right?
Mm-hmm.
So here you can say like only 50 requests are allowed at a time. Okay.
Okay.
Either you can handle it by this, either it will be handled automatically by the back pressure that is applied on your server. Here.
Oh, yeah. How about this? In the API policy, we are define rate limitings. Yeah.
Mm-hmm.
So, and here maximum concurrency. So what is the basic difference? So,
Okay. So if you are defining that in the policy, okay, that means you are defining it in the interface level. You are not coming till here as well. That is the first level of security. Okay.
mhm.
So first it will go through the interface, then only it will come here. If you are adding it there, that means it is at the first level of security. But if you want to add it here at the implementation level, then you can add it to the flow. Okay.
Okay. So if we added both like here and also in the API policy, are you going to implement
That will
both?
be that will be first executed. Okay. Then only this will be executed. Okay. So
Only this
if
one, not
let's
the.
say in the rate limiting, no. If in the rate limiting, let's say you have allowed 100 requests at a time in 1 second.
Yeah.
Okay. So that is inside 1 second you are allowing that. These are
Uh-huh.
concurrent values also. So this is the difference that you need to understand. These are concurrent values and that is inside the particular time span. That is also the difference. So inside the policy, you are saying that in 1 minute, my 10 requests are allowed. Okay.
Okay.
But here you are saying parallelly, my 5 requests are allowed. So this is for parallelly. Concurrency is always like parallelly. Okay. But that policy is will be executed first, then only it will come here. Let's say if at the policy level it gets failed, if you're getting more requests than 5 requests in a minute, then it will get failed there only. It will not even come here. Okay. But if it is coming here and parallelly you are getting 5 requests, then it will get failed. Okay. So this is called for parallelly, concurrent one.
Can you
Okay,
give me
clear?
example? No, give me example.
Okay. 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 If a person is sending the request, the first one is your interface. This one is your implementation.
Okay.
Okay. Interface will be having all your policies and all.
Yes.
Implementation will be having your flows.
Yeah.
Okay. So if you're sending a request for a particular flow, let's say for particular URL for which you are having rate limiting, and that rate limiting says 10 requests per minute. Per minute. Okay. But here inside the flow, you are saying 10 requests in the concurrency. Concurrency value is 10. Okay.
Okay.
From here, in a minute, let's say if you are getting more than 10 requests, you got 11th request also, then it will get failed here only. It will not go to here. Clear?
Right.
First thing.
Yeah.
But let's say this is 20. That is 20 requests are allowed per minute. Okay. And there are 10 users.
Okay.
Okay. And 10 users at the same time hit the same APIs.
Yes.
Okay. So this will pass because here 20 requests are allowed per minute, right? So this will pass. They will go here. And here it says that the maximum concurrent value was 10. And let's say here 11 people were there. Okay. So this will get failed because parallelly it got 11 requests.
Yeah.
Got it?
Okay.
So here it
Yeah.
cleared the first step, interface one, but here it got failed in the implementation level. Clear?
Yeah. So I understand now. So why we need for the flow level to create this, because like the
Because this is
implementation
for
level.
parallelly. Parallelly, how many requests can be executed? Let's say there is a very difficult transformation is there, very complex transformation is there, right?
Okay.
So parallelly, your threads, your RAM will not be able to handle this much of requests. At that time, you can say parallelly, I can accept only 10 requests because I can work on 10 requests, 10 threads at a time, not more than that.
Okay.
Clear?
Okay. Right.
This is
Right.
different. Rate limiting is different. This thing is very much different. This is related to parallelly like parallelly how many requests you can accept. But this is like in a time span, in a minute or in an hour, in a second, how many requests you can accept.
Okay.
Okay.
Makes sense.
So there is a
Yep.
huge
Yep.
difference there. Okay. Let's go back. Okay. So this was related to the back pressure. Manually I explained. Okay. Automatically it is already done. Mule 4 automatically handle that.
Okay.
Okay. Now there are multiple types of threads. Okay. Let's say execution types. Okay. So there are three types. First one is IO intensive. Okay. IO
Mm-hmm.
intensive are the blocking ones. That means you will be using some resources. Okay. That
Mm-hmm.
means like JDBC, like sorry, database connector is there, or your Salesforce connector is there. So these always use your IO intensive. That means you are connecting to something. Okay. So whenever you are connecting to something, some other tool, then it will use IO intensive.
Okay.
Okay. Next one is your CPU light. Okay. CPU
Mm-hmm.
light is for 100% non-blocking. That is where it will be processing in less than 10 milliseconds. Okay. So
Okay.
you have loggers, right? Loggers can
Yeah.
come in the CPU light. That means you are not doing any complex processing. You are not connecting to the third tool. Okay. It's a very
Mm-hmm.
simple one. It is only taking less than 10 milliseconds, and you're
Okay.
not
Okay.
blocking anything. Okay.
Mm-hmm.
Next is your CPU intensive. That means that is taking more than 10 milliseconds and there is some blockage will be there. Okay. That means let's say you are having a data weave transformation that is bit complex. Okay. In that case,
Mm-hmm.
you will be storing your data in the RAM for that particular time, right? So you are blocking the RAM, right? So, and it
Okay.
may take more than 10 milliseconds. So it will be using your CPU intensive. Okay. So
Okay.
these are types of thread pools you can say. IO intensive, CPU light, and your CPU intensive.
Okay. Okay. Like,
Okay.
how about the memory? We don't have anything. Only which one is like this is only explaining the CPU and I/O. How about the memory? Sometimes
Yeah,
some
memory also, like if you are using memory will also be like a part of this only. If you're blocking something, you're using memory. Okay.
which
And
one?
then namings are given like this: CPU light and CPU intensive, right?
Okay.
Inside it will be using the memory also, but the names are like this. Okay, CPU light and CPU intensive, because it is based on the throughput, like how fast your process is executing, right?
Let me ask you one question. So sometimes when you are like adding these loggers in our flow, we
Hmm.
are so sometimes when you add more logger,
Hmm.
it's is not good for memory. Yeah, so we consume a lot
Hmm.
of memory.
Hmm.
So how do you define that here? So where do we intensive like using for
Okay.
uh,
Hmm. This is for all the components. This is not flow based. This is for component based. Okay, that means this DB component will be using IO intensive.
okay.
Okay. You remember I explained you this listener and uh, request connector that Grizzly will be used, right?
Uh-huh.
Similarly, for the connector, okay, for that DB connector, your IO intensive will be used because you will be
Hmm.
connecting to the third party, right?
Okay.
And CPU light for those connectors which are not involving any difficult calculations, which are not involving any blockage. Okay,
Hmm.
this will include in your CPU light. That will use your CPU light. Thread pools, these are like a thread pools. Okay. Next is CPU intensive. CPU intensive, like your transform message is there, which is having some data weave transformation, which is the difficult one, complex one. At that time, it will be using CPU intensive. Okay. So let me tell you one more thing. Whenever you run any program, okay, whenever you deploy any program, let's say I deployed this one. Okay. So here
Hmm.
also you will be able to see that. mm, just a second. Start with. Okay, this is running now. Give me a second. So if I execute this, see, CPU intensive. Okay. So
Mm-hmm.
for the particular connector, for this particular connector, I'm not sure for logger. In this case, for logger also, it used CPU intensive. See,
Okay. Okay.
okay. So
Mm-hmm.
you can
Mm-hmm.
see here as well which thread pool is being used. Okay. So earlier there were different thread pools, separate thread pools for IO intensive. There was separate one for CPU light and separate for your CPU intensive. Okay. But now there is Uber thread pool, UBER. Okay. In Mule 4,
Yeah.
the Uber thread pool is being used, and inside Uber, it automatically detects which which will be using internally CPU light, which will be using internally your CPU intensive, and which will be using IO intensive. It will handle everything by itself. Okay. So in the deployment, when you deploy, you will be able to see that Uber is used.
Okay. Yeah.
Uber this intensive and all. Okay. Let's go back. And as I told you, what you can do, uh, you can download this visual VM. Okay. Oops, sorry. I just opened this. I want to open this as a. Okay, leave it for now. Okay, see. So whenever you will open this visual VM to, okay, so you will find like for each and every Java application that is running in your PC, this one will be created. Okay, this application will be created. So
Mm-hmm.
for this application, this one is created for my Mule one. See, this one is for my Mule one. Okay. So here you can open this and you can go to the threads and you can see what all threads are executing. See, Uber 1, Uber 2, Uber 3. Okay. So
Mm-hmm.
this tool is very helpful to see how threads are working behind the scene. See,
Mm-hmm.
HTTP requester connector is there, right? So
Okay.
these all will be useful only for your on-prem deployments. Okay. It will not be
Mm-hmm.
useful for your Cloud Hub because Cloud Hub manages these things by itself, right?
Automatic. Yes. Mm-hmm. Yeah.
So, but if you are having on-prem, then you can check this out. You can to
Okay.
understand how things are working behind the scenes. Clear?
Okay. Okay. Yep. Clear.
Okay. Okay, every Mule component is assigned to one of the three execution types. These execution types. Okay,
Yeah.
you can manually note the source code. Okay, so for everything you are having a source code. For everything you are having a source code. Like Java is there. From where I can show you Java classes. I don't think so. It will open here because this is a dot class file. Okay, so whenever you create a file, okay, whenever you try to decompile this file, inside that code also you will be able to see the annotations. Okay, and you can provide your own annotations as well, that manually defining that it will be using CPU intensive, like that.
Mm-hmm.
Clear?
Okay. Okay.
Or otherwise it will be automatically predicted. It will decide by itself. You know how it will be decided based on these things.
Mm-hmm. Mm-hmm.
Okay. Okay, next it says how Mule 4 runtime self-tunes performance. Okay, Mule 4 uses the scheduler execution service to go this. Okay, this diagram is self-explanatory. Let me show you this diagram. We are having HTTP listener, right?
Okay. Yep.
HTTP listener will be using shared grizzly, correct?
Yes. Yes.
Next is your database select. Database select will be using blocking IO, correct?
Mm-hmm.
Next we are having logger. Logger will use CPU light.
Okay.
Next we have data weave. Data will use CPU intensive, right?
Okay. Mm-hmm.
Next we have again logger that will use CPU light. Clear?
Mm-hmm.
Next we have HTTP request connector that will be using your dedicated grizzly, right? Remember?
Correct. Yes. Yes.
So now it is understood how they will be divided, how they will be used.
Mm-hmm. Mm, fine. Okay.
Okay. But in case of listener and in case of requester, see the request is there, the response is there. Correct?
Mm-hmm.
So for the listener, the request is there. The request will be using shared grizzly as we have studied. Okay. Then the request will be sent to the next connector. Okay. For sending the request to the next connector, behind the scenes, it will use CPU light. Okay.
Okay.
Because you are coming from source to the event processing. Clear?
Okay. Okay.
You are coming from source to event processor. So here, this one will be using blocking IO, right? This one. From blocking IO, the logger will be using your CPU light, correct? Clear?
Okay. Okay.
Okay. And this data weave will be using your CPU intensive as we mentioned.
Mm-hmm.
Clear?
Okay.
Next, from here also this logger will be using your this
L-
logger will be using your CPU light. Clear?
Yes. Yes.
But for
Mm-hmm.
the requester, you remember I told you for the requester only the response will be considered. Okay.
Yes. 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 Correct.
Okay. So see, for the response only we have this dedicated grizzly.
Mm-hmm. Mm-hmm.
Clear? But for
Yeah.
sending the request to the endpoint, it is still using your CPU light. Okay. Because only for the response it uses dedicated grizzly. Clear?
Mm-hmm. Mm-hmm.
Then the response will be sent to your HTTP listener that will also use your CPU light.
Okay.
So for listener, for the request, your shared grizzly will be used. For the requester, for the response, your dedicated grizzly will be used. Clear? This
Mm-hmm.
diagram is easy to understand.
Yes. Yes.
Okay, let's move on then. Again, this diagram is explained. Okay. Okay, now it says that internal differences between Mule 3.x and earlier versions. Okay,
Okay.
proactive pattern is applied the exact same way in all the versions of the Mule 4. Okay, so these things, these thread pools and all is applied to all the versions of the Mule 4. Okay, Mule 4.1 and Mule 4.2 used a separate thread pool. Okay, 4.1 and 4.2 was using the separate thread pool for each execution type. As I explained you that it will be having CPU light, it will be having CPU intensive and your blocking IO. But after that, and from 4.3, one Uber thread pool is there, okay, which will be internally dividing this. So here you will be able to see the Uber ones. You are not able to see CPU intensive and CPU light. Okay, so
Mm-hmm.
there is one file which you can update, like in the configuration. I think I'm not that sure. Mm, in that Mule, no, not this one. Not that sure. Inside this should be the scheduler thread, scheduler pools. See, open this one. Let's say opening in Notepad. Okay, and search for Uber. Okay, so earlier
Uber.
it was dedicated and now we are having Uber. So if you want to see CPU intensive and CPU light threads here, what you can do, you can change this Uber to dedicated in the file. Uh,
Okay. Okay.
Let me show you where. This one. No, not this one. Okay. See, here you need to comment out all these lines which are inside this Uber one. Okay. So whatever
Mhm.
that is there in the dedicated one, you need to decomment that. Okay.
Okay. Okay.
Then only you will be able to see the difference. Clear?
Yep. Yep.
Okay. So now it is explained that everything will come under Uber thread pool. So this diagram
Mhm.
is clear now. Correct?
Yes. Yes.
So try scope with the transaction. This was not the part of see. This is not the part of the slide. Okay, this is I just copy pasted from somewhere else. So we will be covering transaction. Once we will be covering transaction, then you will be able to understand this. Okay. So
Mhm.
always remember for a transaction only one thread will be used. Okay, because
Mhm.
transaction means either done or either one or zero. That's it. Okay. So in banks, we have transactions, right? Either your money will be sent, either it will say no, it got failed. That's it. Your
Yes.
money will
Yes.
not get vanished and all, right?
Mhm. Mhm. Correct.
So that will come under transaction. That means only one thread is used for that. In case there will be any issue in between, it will roll back each and everything. Okay.
Mhm.
So these are related to the transactions. Okay. Describing the synchronous mule event processing. Okay. So for synchronous, the features of synchronous processing will be like processing of a single event is performed on one dedicated thread. Okay. So one dedicated thread will be used for the flow. Okay. The main thread blocks and waiting for the called worker thread to complete the execution. Okay. The entire request and response is handled synchronously in one thread. Okay. Transaction, as I mentioned, that transactions are always processed in a synchronous mode. Okay. Transaction
Mhm.
scope. So there is one scope, like your until successful and all, there is one scope called transaction.
Is that transaction manager?
Mm, now,
Okay. We have transaction managers. Yeah.
not this one. Transaction manager where? I think here it is there. Sorry. Transaction type and transaction. Yeah. Inside the try block, you can see that. Okay.
Mhm.
And other connectors, it is there or not? No, it's not there. So there are few connectors which allows you for transactions. Okay.
So okay. So what is the difference between the other transaction manager? So, for example,
Which
when we are
transaction
using,
manager?
so when we are, for example, this is the one I saw it like transaction action transaction type, which means when we are trying to insert data into the database, for example, if connection issue or something is happened, so it's rollback to the rollback. So and after sometimes it's going to reconnect again.
Mm-hmm.
So
I think yeah, rollback will be done here as well. But transaction manager and transaction is a different thing. Transaction will be for the entire flow as well, or you can have a transaction in a try scope, or you can have it as a individual connector level as well.
okay.
Okay, so if the connector's listener operation starts with the transaction, okay, then the transaction scope is for the entire flow. Okay, so as I told you that it could be for the entire flow, it could be for the uh, connector level, and it could be used as a for some
Mm-hmm.
connectors by using the try scope. Okay, so if you want to use
Okay.
it for the whole flow, what you can do in the listener only, you have to configure this. So in listener, it should have not here inside. Mhm. Where it is, this is different delivery. Up in the flow also. Let me check. Sorry. Because it says that if the connector operation starts the transaction scope is for the entire flow, as it says.
Mm-hmm.
Okay. Okay, so this listener, that is a JMS list. Okay, okay, okay. So transaction is can be used for some connectors only. Okay. I
Uh-huh,
remember
yeah.
that. I forgot. Sorry. So it cannot be used for this listener. That's why we are not getting the option. Okay. So if
Okay.
we are having GMS listener, then it will be used. Okay. So there are few connectors which will be using your transaction. Okay. That we will be covering in our next modules, I think, where we will be learning about the transaction. Okay, in detail.
Mm-hmm.
Some connectors may use their own thread pools. Okay. So those connectors are your listener and your requester HTTP connectors. Grizzly thread pools are used, right? Dedicated and shared ones. That's what explained here. Okay. This one. See. So
Mm-hmm.
this walkthrough is already done. Understanding the fundamentals of web APIs. Okay. So understanding the HTTP. Okay. Asynchronous and stateless communication, it is related to the HTTP. You can search it out. That's easy. Like server is there, client is there, sending the request and receiving the response. Okay, those are the normal ones, things that are already available on internet. Okay. So the structure of HTTP request and HTTP response, that is explained here. That the first line will be there, that will present this. The start line will be having this method, and HTTP version will be there. Okay, and in the response you will be getting the HTTP version and the status. Okay.
Okay.
Then in the request headers will be there, then the request body will be there. That could be optional. Let's say if you are having a options call, or if you are having a get call, get method, in that case you don't need request body, right?
Mm-hmm. Yep.
So in response also, response headers will be there, response body will be there. Okay, that will be also optional. Let's say if you are deleting something, then you may get 204, right?
Mm-hmm.
Next is understanding REST. REST also, I think you can search it out on Google. That will be better. This will not give you correct like detailed information. Okay, REST. I can say that it is an architectural style that we follows. Okay, so people always like get confused that REST and HTTP are like exchangeable, like they are same, but no. Okay, HTTP is a protocol that works only for HTTP methods are allowed. Okay, but REST APIs may have the protocol HTTP, and it may have other protocols also. Okay, REST APIs may have other protocols also. So it is not just with the HTTP, but in Mule we have HTTP with the REST. Okay, but
Mm-hmm.
REST is architectural style and HTTP is a protocol.
Okay. Okay.
Okay, and practice HTTP methods. Okay, these methods I have already explained: idempotent, non-idempotent, and safe, non-safe. I have already explained. Okay. Understanding how the soap messages, this also we have covered, like how soap will be getting the data, like how the consume will be used, right? We
Mm-hmm.
covered
Mm-hmm.
this one. How REST methods compared with the SOAP operations. Okay, so you are already aware that in the REST we have methods, these post, get, put, and all, right? But in SOAP it will be always post. Okay, always post, but you can
Post.
define the operations. Okay, but the method will always be post for SOAP. Okay,
Is that usually or always? We
always,
can use
always.
either method.
Always. With SOAP, you can only use post method. None of other methods are allowed. You can check that on Google as well. SOAP always have post method. If
Oh.
you want to get the orders data, then in the operation, in the action, you will be defining that it is for get orders. But the request will be, the method will always be post. Okay.
Mm-hmm.
Okay. And this is the important slide. You can take the snapshot for this one.
Okay. Okay.
5 minutes more. Okay, for soap, what all things are allowed? Okay, so for soap, WS hyphen star is allowed. There are standards for security. You can use WS security. Okay, WS atomic
Mm-hmm.
transaction is there for acid transaction. Acid means atomicity, consistency, and I will be, I think, I was D is durability. Asset properties. Asset properties. I is isolation. Okay. So
Mm-hmm.
atomicity means only one. Okay. Consistency means it's like it says that if you are updating something in the one table, it should be updated in other table also. Let's say the address, student's address is there in two tables. For same
Uh-huh.
student, if you're updating in one table, it should be updated in another table also. Isolation means one transaction should be isolated with other transaction. Okay, they should not like use the resources of each others. Next is durability. Everything is on time. Either say yes or either say no. That's it. Okay. So atomic transaction, then reliable messaging is also there. Okay. So you have already taken the snapshot for this. These are allowed in the SOAP. Okay.
Mm-hmm.
Understanding the fundamentals of event-driven architecture. How many pages are done? We have 2-3 minutes. We can cover this one. Okay. Okay, understanding the event-driven architecture. Okay, the event-driven architecture is also the architectural style where your message broker will be used. Okay, your consumer will be there. That means one producer, then by via message broker, the message will be transferred and it will be consumed by the event consumers. Okay.
Mm-hmm.
So in this case, let's say example, you have a JMS, then JMS broker will be there. And let's say there are multiple consumers to get the message from that JMS queue. Clear?
Mm-hmm. Mm-hmm. Yep. Yep.
This is message driven architecture. Uh, okay. I gave the example for JMS, but here let's have this will also come under event processing only, this event driven only. But let's say for now, you can consider this as an example for VM queues and all. In JMS, we are having queues also and we are having topics also. Okay. So queues are for one to one. That means only one publisher will be there and only one consumer will be there. Okay.
Mm-hmm.
Whatever you
Mm-hmm. Yep.
published in the queue, that will be consumed by that person. But if you're having topics, that means you can have multiple subscribers. Okay.
Uh-huh. Yeah. Yeah.
So one publisher and multiple subscribers will be there. Okay. So this is a difference between queue and topics. As I said that in the queue, zero or more, and in topic it will be one to many, and in the queue it will be one to one, right?
Uh-huh. Yes. Yes.
And in the queue the message persists, but in the topic message may get lost. Okay. Let's say if one subscriber is not available at that time. Okay, that means message will get lost. But in the queue, if the receiver is not available, then message will be persisted in the queue. Clear?
Okay. Yep. Yep.
So now it says how to use the JMS connector. That again the same thing, queues and topics, and what is the meaning of queues and topics. So in the JMS, you can see we have publish consume, we have consume on new message, acknowledgement, ACK. Okay. So there is a difference between publish and publish consume. Okay. This publish
Mm-hmm.
will always works in a asynchronous way. That means it will
Okay.
not respond. It will not wait for the response. It will not wait for the message to be consumed. Okay.
Uh-huh.
But publish consume, this this fifth one will be used for the synchronous one. That means inside it will be asynchronous. It will publish the message and it will wait for the message to be consumed, then only it will go to the next connector.
Ah,
Okay.
okay. Mm-hmm.
Mm, yep, same thing is explained. Publish, send the message, asynchronous delivery will be there. Consume means getting that is receiving the message, the receipt one. Okay. And on new message is that the triggers one. Okay, simple thing. Publish consume is synchronous, as I mentioned. Okay. It combines publish and immediate blocking and consume the operations and blocks until the response is received or the timeout expires. Clear?
Yep. Yep.
Okay. The order in which messages are delivered to the consumers of the JMS queue. Okay. So the order will be same as the order they have received. Okay. That means if you have received first message, or you may be aware of the difference between stack and queue, right?
What in
Queue
what?
is
Sorry.
always stack versus queue.
I only know Q. What's stack?
Yeah. Okay. Let's forget that. That was a college terms, no? So I thought I can explain you by comparing with that. Okay. So queues are always like first come, first go, right?
Yep. Yep.
So whatever the message you are getting first, that will be processed first. This is what explained there. Okay. Uh, okay. Now, Anypoint MQ. Anypoint MQ is only available for your Cloud Hub. It is not there for your on-prem. Okay.
Yep.
So Anypoint MQ is fully integrated with Anypoint platform. Okay. Role-based access control is there. Client application management is there. Anypoint connectors and the web UI and the REST APIs. It supports the communication between non-Mule applications and the broker using REST APIs. Okay. Okay. So here also what we have a standard queue. Okay. That means single subscriber will be there. Some single publisher will be there. Okay. Without strict ordering preserved. Okay. Next is first in, first out. Okay. That I said that whatever the message you are getting, that first, that will be processed first. So here we will be having strict ordering. Okay. Next
Okay.
is message exchange. Message exchange will be similar to your topic. Okay. That means you are broadcasting the single message to multiple queues, but here you are like sending it to multiple queues. Okay, that will be consumed by single consumers. Clear? In the
I have one
topic,
question. So,
yes,
sorry.
yes,
For
yes.
exchange, like it looks like topic,
Hmm?
but we are multiple. Okay. Okay. So, yeah. Yeah. I thought
Yes.
like in the
There's a
exchange it
different.
looks. Yeah.
No,
Yeah.
no, no. That is different, different, different.
Mhm.
So in topic, there was one publisher. Okay,
Mhm.
and with the topic, the data is being sent to multiple consumers. But here, with the exchange, you are getting the data by multiple queues. Okay, and then
Mhm.
consumer will extract the data from that queue.
Okay.
Okay.
Okay. Yeah.
Then how Anypoint MQ distributes the messages. Okay, in Anypoint MQ, reliability is provided via queues. Okay, through a lock and acknowledgement mode. Okay, in the queues there will be acknowledgement mode. A consumer retrieves the message from the queue. Okay, consumer will receive the message from the queue, and this locks the message for the finite period of time and makes the message invisible for other consumers.
Okay. Okay.
Okay. And if the message is not being processed within the lock period time, the lock time out and consecutively the message is made visible to other processes. This you can, I think, read it out. I'm not getting it clearly, but it says that if there are, see here, exchange is being used. Okay, and exchange is sending the data to multiple queues, and from one queue, let's say one consumer is receiving the data.
Okay.
Okay, he will receive the data at a time, but it yep, he will receive the data, and let's say if it will not be able to receive the data, then how it will going to happen. This is what explained here. Okay, so if it receives the data, it will be locking it for some period.
Okay.
That's
Okay.
what it says. Okay. Mhm. Then VM connector, how much is left? I think we can cover it tomorrow then. Okay.
Okay. So
Let's stop
I
here.
have one question. So not related with this one.
Mm-hmm.
Uh, with the previous discussion, like when we starting this morning,
Mm-hmm.
for error handling mechanism.
Okay.
So, but my question is like, So some can you go to runtime manager, please? The endpoint
Okay.
platform. Yeah. Okay. Can you open the runtime manager?
It may ask me to log in.
Okay. Okay. So yeah.
Mhm. It's not allowing me because it got expired. Yep, runtime
Um,
manager. There is
yes.
no
So
application deployed. Yep.
okay. For example, if you have like different APIs here,
Mm-hmm.
process system, whatever,
Okay.
and it's like in production. Just assume this API is already in
Hmm.
production.
Okay.
In production. So when we are like testing or something is error sometimes happen in the production, the API itself. So how we going to handle this error? Like
Which
so
error?
for example, we after we are deploying, assume it's a QA. So we are testing in QA. So
Mm-hmm.
this application API. So
Mm-hmm.
when we are like testing, running this application, we got error.
Mm-hmm. Okay.
For example, connection error. So I usually do, for example, I go to, if it is something, one API or something, it was easy for us to
Mm-hmm.
check, go to the log,
Mm-hmm.
and I just run the application and I check logs. I usually do like that. If it is, for example, queue like a scheduler, I checked the log. Uh,
Mm-hmm.
so we and how we going to download the log, something like that. We are how we going to process the error like here. So we are defining error continue, error propagate, anything in the Anypoint studio, and once everything testing the
Mm-hmm.
so we deploy here. Yeah.
Mm-hmm.
So in this testing, the actual FUT
Mm-hmm.
functional testing,
Mm-hmm.
sometimes it fails. How
Mm-hmm.
we going to handle that error?
Okay. There is one like one way you can do this. Like for each flow, what you can have a logger in the starting and in the end, where you can
Right.
say that this flow is starting, and in the end also you can say that this flow is ending. Okay.
Uh-huh.
In that case, in the logs, you can directly search that this flow got failed. This so that you will be able to find out at which flow your error occurred. Okay. First thing is that. Second thing is always go with the correlation ID. Okay. Always
Mhm.
in the response try to give the correlation ID. If you're not even giving it, you will be getting that in the headers. Okay. So whenever you send the request in the headers, you can see, I think here also you may be getting it. No, no, here it is not showing. But in most of the cases, you will get the correlation ID. If you're not getting it, please send it out in the response so that the customer will be able to understand this correlation ID got failed. With that correlation ID, go to the logs and search for that correlation ID. Based on that correlation ID, you will get each and everything, each and every error for that
Oh.
particular uh,
Mhm.
hit. This is how you need to debug the issues. Okay. So error handling is basically, it's not to handle each and everything. It is basically done to make the customer understand that if this is the error, then how the notification needs to be sent and what the action needs to be done, that you are
Mhm.
providing. Let's say if there is one error that is related to the timeout, for that error you want to uh, send the information to the customer that this is the correlation ID, this is the server that we were trying to reach, and for this we got the error. Okay. So this is
Uh-huh.
what you will be adding in the error handling. let's say in the transform message, as a output,
Okay.
as a payload that will be printed as a payload. Okay.
Mm-hmm.
So what
Yep.
you have to do in that case, there is one more thing. So in listener, okay, in the responses, you will always see that here in the body it is error dot description. That means you
Yeah.
are printing the error body. You are not printing the payload. Okay. So in that
Yes.
case, what you can do, you can remove this, you can add a payload, and in the error handling you can add a transform message. Okay. And then
Okay.
in the response, that payload will be printed, not your error description. Clear?
Mhm. Okay. Yes. Yes.
Okay.
Yep. Yep.
So yep. Okay then.
Mm.
Yep. See you
Mhm.
tomorrow.
All
So
right.
I think
Thanks.
half is completed. We can say that. Not half, yeah. It is too much. But most of the cases are completed till here only. Because I'm worried. I haven't got even a single penny. Yeah, that's why I'm a bit worried. They are saying that complete the half course, then only they will pay. So can I say that half is done?
Uh, I don't
Tomorrow, after
know.
tomorrow, I will say.
So
Because it was said that this course will be for 35 hours, right? But I think
yeah.
the speed that we are having for now, it will go beyond that, right? You also think
Yeah.
so?
So I don't know the plan because I only see the module how we going to, you are
This is the
covering.
first time, yeah, this is the first time even I'm working with them, and even I don't know like how they work. And they asked
Mhm.
me to create my own data. So this is my own data that I created, and this is what I already have, right? You can see that I always write my own code to show you, because I don't have anything. I haven't received anything from a CourseJet. This is my
So
personal data
I
and
don't know
everything.
which one is. You're right. Which one is? I don't know. Half for me. I can say this is half. Where we are like it's like mandatory to cover. I don't know about this one. Like I saw like 16 is module. We are in 4.
Hmm.
So yeah. So I
I'm
don't know
saying half
how.
because these are not like, see,
Mhm.
this is having the slides, not the slides, sorry. Okay, this is all the theoretical part. Most of the theoretical part is there, and you can see that these are related to the runtimes like control plane, and that we have already covered. See, vertical scaling,
Okay.
horizontal scaling. We have already covered this in till fourth, because every time when I was getting any term, I was explaining you that, right? You already
Yes.
know
Yes.
that.
Mm-hmm.
So so that we can skip it in the future, right? So
Okay.
that's why
Okay.
I'm saying that tomorrow I am thinking to call them and say that half of the course is completed, so
Uh-huh.
that even at least I will get some pay.
Oh, okay, okay. For that, you can do
Okay.
that. For me, like
Yeah,
I thought, like we are covering everything. Okay, okay. For sure,
yeah,
sure,
yeah.
you can.
We will be covering everything, but for now I'm thinking to tell them that half is done, because we
Okay,
have
okay,
already covered the points, right?
okay, okay.
I'm not going to
So,
miss anything, but yeah, okay.
okay, okay,
This
okay.
is for them.
Go ahead. That one. Yeah, yeah.
Yeah. Okay then.
Sure.
Okay.
Okay.
After
All right.
tomorrow's class, I will tell them.
Sure, sure. Yeah, you
Okay.
can do that.
Yeah.
Okay.
Thank